Discuss about 8085 instruction set. So there are different types of instruction set in 8085. First of all, number one is the data transfer type instruction. The first type is data transfer type instruction. This data transfer type instruction is basically, there are different types of, that means register to register transfer, register to memory location. This is also a data transfer type, or either memory location to register transfer, or there are so many, register to IO port or IO port to register. So there are different types of data transfer type instructions are available. For example, in a 8085 instruction, basically there is a two concept. One is opcode and one is operand. Okay, the creation of instruction is the addition of these two things. Please noted that these opcode and operand, these two parameters are addition with these two parameters can create the instruction. So what is a opcode? In a 8085 microprocessor, there are 74 different types of opcoder available. First opcode is known as move and the operand is move, means the transfer instruction or move instruction, and the first type is the destination register and the source register. So for example, if we write move A B, that means the data transfer from B register to A register, not A to B, B to A, and after transfer, say the content of B is 07 hexadecimal number. So after perform this instruction move A comma B, the data in this register 7 in register B is transferred to accumulator, but the data is not deleted here, it's just a copy paste. Okay, like in a computer we just write, we just copy paste the file, so it's similar like that. So the next type of instruction is, so first of all, there are different types of move instructions are available, because in a microprocessor 8085 there are basically B, C, D, E, H, L, M and A. There are 1, 2, 3, 4, 5, 6, 7, 8 registers are available. What is M? M is basically a memory pointer. Okay, is a memory pointer. Memory pointer means the memory which point out the register value. Okay, so there are lots of examples are available. Move C comma D, that means the value of D register is transferred to the C register, like that. So next type is MVI. MVI, the format is MVI, the full form is move immediate, and the format is move 8-bit register and 8-bit data. 8-bit data, this 8-bit register. For example, if we write MVI B comma 07, that means this 07 hexadecimal data is directly transferred to the B register. Okay, so this is the move immediate operation, which is very important. This is immediate type instruction, that means data is immediately transferred to the register. Next type is LDA, 16-bit memory address, 16-bit address or memory address. That means if we write LDA 8000, that means from the memory location 8000, the 8-bit content, the 8-bit data X, let us say the 8-bit data is XX content here. So what is the meaning of LDA? Load accumulator direct from this location. I again repeat, load the accumulator from this location. That means after perform this instruction, the accumulator content is XX hexadecimal number. Okay, this is another instruction. So the another instruction is LXI H. LXI means load immediate register pair. These X symbol means pair. There are different types of instructions available, like LXI H. Here 16-bit data or address also, both are applicable. LXI B as far as follows the same rules. So and one also register perform here, that means stack pointer. But in today's in this lecture we already discussed about this user defined register, that means programmable register. So if we write LXI H FFB0, that means our HL pair content is FFB0. okay, this is look like that. So these all are the data transfer type instruction. Now number 2 is the arithmetic instruction. Arithmetic instructions. So what is arithmetic instructions? Just perform the addition operation. For example, add 8-bit registers. 8-bit register, not data. Okay. These add means addition with accumulator. By default, this in 805, this add means we add accumulator plus which register is include here. For example, here we include B. That means A plus B, and after perform the result, the content is saved in the accumulator. Okay. So another example, like add D, that means accumulator plus D register both are added to each other, and result is stored in the accumulator. So this is the operation of add instruction. So here add is opcode, and these 8-bit register operand. So opcode, I again repeat, opcode plus operand equals to instruction. So in the previous time I say that LXI, LDA, these all are opcode. Okay, these all are opcode. Just say about that. Now next, our next instruction is addition immediate. Here we include not 8-bit register, here we include 8-bit data. For example, if ADI 0F, that means accumulator data plus this 0F data is immediately add and stored in the accumulator. Okay. Next instruction, ADC, 8-bit register. That means accumulator content plus this 8-bit register content plus with this carry flag. What is a carry flag status? Either 0 or 1, and the total summation is stored in the accumulator. For example, at ADC H, that means accumulator content plus H register content plus carry content. This total summation is saved in the accumulator. So there are lots of examples are available, like a sub, that means subtraction of 8-bit register. This means accumulator minus this 8-bit register and the content saved in the accumulator. Next, subtraction with borrow. This is a 8-bit. Next instruction is a ACY, 8-bit data. This ACY means subtraction immediate. That means accumulator minus this 8-bit data is saved in the accumulator also. Okay. There are different types of arithmetic instruction are available. Just a few of them I discuss. Now in the third part, the most interesting instruction are logical instruction. So first of all, OR. What is the meaning of OR? That means OR operation with accumulator. Here we include 8-bit register. That means accumulator content plus this 8-bit register content, they are OR operation to each other, and the result stored in the accumulator. For example, OR D, OR C, that means accumulator content plus C content are OR operation to each other, and the result saved in the accumulator. So like a similar instruction, like a OR, the next instruction is ORI. ORI is with 8-bit data, not register. ORI means OR immediate. That means if we include ORI E, that means accumulator content plus E content, 8-bit data. That means here we include any data like AFF. So here, here FF, this is FF. Okay. So accumulator plus, but not a plus, this is OR operation, and the result stored in the accumulator. So like a similar OR, there also exist like a ANA. ANA means AND operation performed. If ANA 8-bit register, that means accumulator AND operation performed with this 8-bit register, and the result stored in the accumulator. Next, ANI. ANI means AND operation immediate with the 8-bit data. This is a register. Okay, this is a register with a and this is a data, not a register. So this is an instruction. Next instruction is Xor operation. The Xor operation is basically named as XRA with 8-bit register. That means this XRA means Xor operation with accumulator. Which register? Those register I include here, or I mention here. That means if I mention XRA B, therefore accumulator Xor operation with B and result stored in the accumulator. So result stored in the accumulator. It looks similar like that another instruction XRI. This is performed by the 8-bit data. Okay, so accumulator content plus 8-bit data XOR between XOR to each other, accumulator and 8-bit data XOR to each other, and the result stored in the accumulator also. So these type of instruction are known as the logical instruction. Okay, so next instruction is number 4, branch and control. This is a very serious and very important, because in a branch there are basically two different types of branch. Number 1 is conditional branch, and number 2 is unconditional branch. Unconditional branch, there one instruction is exist, that is called jump, and here we include 16-bit address. Any jump instruction is the operand is 16-bit address, and the conditional instruction is depend basically on the flag register values. So how many flag register exist in 8085? First of all, carry flag. So depending on this carry flag, there are two jump instruction exist: jump if carry, jump if no carry. Here mentions operand is 16-bit address. Here also a 16-bit address. Next flag is parity. So depend on this parity, there are two jump instruction available: jump if even parity, jump if odd parity. Next is zero flag. So depending on this zero flag, there are two branch instruction are available. One is JNZ, and number 2 is jump if no zero, jump if zero. And last one of very important, sign flag. Depending on the sign flag, there are two instruction available: jump if minus and jump if plus or positive. And here also operand are 16-bit address. Okay, so these all are known as the branch and control. So in the later part, when we discuss about the assembly language programming, and then we show that how these branch and control instruction executed and control the whole operation in the microprocessor, and how they are changing their decision depending on this flag value or the result value, or different types of orientation or sophisticated type of coding. Okay, now next part is number 5, is known as machine control instruction. There are several machine control instruction, but I mention only the few instruction. First of all, halt means it stops the execution of the machine. That means no other further process are running in the microprocessor. So halt is a machine control instruction, is also a machine control. And there are different types of machine control instruction, like no operation, NOP. No operation means there are no operation are performed, but microprocessor in the no operation, microprocessor cannot stop the program. We cannot perform any operation using this NOP operation. Okay, but halt means it takes an action for which the microprocessor totally running or execution, there are no execution are performed after the halt operation. So there are another types of machine control instructions are also available. So that's all for today. Thank you.